Hello, this is Schedulytics and welcome to today's session. In today's brief video, we'll be taking a look at one sample t-test. Now, one sample t-test talks about comparing a known mean of a sample to a given specified mean or specified mean. So here you have a hypothesized mean that is obtained from another study, and then you are now comparing your sample, the mean of your sample, to that particular figure to see if they are the same or different. And since this is an inferential statistics, the null hypothesis is that your mean that you're going to get for your sample will be the same as that of the hypothesized mean. So there's no difference between your mean and that of the specific or hypothesized mean. And then the alternative hypothesis will be that your mean is different from that of the hypothesized mean. Now, when you realize that your variable is not normally distributed, then you can't represent it using the mean. So you have to fall on the median. And when you are falling on the median, then it means you have to use the non-parametric version of the one sample t-test, which would be the sign test. So we are going to demonstrate this using the STATA platform. And so this is just the view of the data we are going to work with. So for one sample t-test, you need to use a continuous variable. So we are selecting SBP, which is systolic blood pressure, and then diastolic blood pressure. The first thing we have to do is to check if they are normally distributed. That will inform us as to whether we should go ahead with comparing the mean with a specified hypothesized mean or comparing the median to a hypothesized median. So we run the normality test, and then it tells us that for SBP is normally distributed because the p-value is not statistically significant. So we fail to reject the null hypothesis, which says that it is not different from a normally distributed data. However, the diastolic blood pressure is statistically significant, and so we can reject the null hypothesis that it is not different from a normally distributed data. So this is different from a normally distributed data. So diastolic blood pressure is not normally distributed, whilst systolic blood pressure is normally distributed. Hence, we will use the parametric version of the one sample t-test for systolic blood pressure, and then we use the non-parametric version of one sample t-test on the diastolic blood pressure. So now so we are assuming that our hypothesized mean for the systolic blood pressure is 132, or let's do 130. Our hypothesized mean for systolic blood pressure is 130. And so the code we need is that t-test SBP is equal to 130. So what this means is that we are saying that there's a study has been done, and it has been established that a given population has a systolic blood pressure, the mean systolic blood pressure, to 130. We are also looking at our data that we have. Is our data, the mean of our data, SBP, is it different from this or not? That is the import of this code. Now let's run it and see. Now our p-value is telling us that it is not statistically significant because it is greater than 0.05. So we fail to reject the null hypothesis, which says that there's no difference. So the mean of our sample and that of the specified or hypothesized mean are generally the same. So that is what we can make from this information we have here. So our data, the mean is what, 131. And we are saying that the population or the hypothesized mean is what, 130. Generally 130 and then 131 are generally the same. And so we fail to reject the null hypothesis that there's no difference between our variable and the hypothesized mean. Now, how about diastolic blood pressure? Mind you, diastolic blood pressure is non-parametric or not normally distributed. And so we cannot use this code for it. And so we have to follow on the sign test, diastolic blood pressure. And we are hypothesizing that our diastolic blood pressure is, let's say, 90. So we run it. So this tells us that we are looking at the two-sided test. The p-value is statistically significant. So it tells us that we reject the null hypothesis that the median 90 or the hypothesized 90 is not different from our population or our sample median. So we fall for the alternative hypothesis, which says that it is different. So our median is different from the specified or the specific hypothesized median. So generally, this is how you can be able to run one sample t-test using the STATA platform. First of all, you have to establish whether your variable you are using is parametric or non-parametric. If it is parametric, you go ahead and run this code where you specify the variable. So this is the variable, and then this is the code you run where this is the variable and this is the hypothesized mean that you are comparing your sample mean to. And if the variable is not normally distributed, then you use the sign test, the variable, and then the median that you are hypothesizing and comparing it to. Generally, this is how you can use STATA to achieve one sample t-test of your variable. This is Schedulytics. If you find this video useful and you like content such as this, we encourage you to subscribe, like, and share our videos. Until we meet again in our next video, it's a bye.